Hello, everyone. Welcome to this webinar by SimScale and Thornton Tomasetti. The topic today is Design Buildings Faster by Harnessing the Power of the Cloud. My name is Dr. Nagman Khan. I'm from SimScale, and I'm delighted to be joined today by our two presenters, Mr. Jeroen Janssen from Thornton Tomasetti and Antol Dama, co-founder at SimScale. Hello, Jeroen. Hello, Antol. Thank you so much for joining us today.
Hi there. Thanks for having us.
Thank you. Jeroen, this is a really interesting topic, and we've had some fantastic demand and interest in this. So we have a lot to cover, and we're going to crack on. Before I do that, let me just introduce SimScale for everyone. So SimScale, we are a German software company headquartered in Munich, and we have developed the world's first production-ready SaaS application for engineering simulation. Now, what does that mean? That means you can simulate on a web browser, on the cloud. You can do CFD, FEA, and thermal analysis accessed via a web browser. As you can see, we have hundreds of thousands of users and projects worldwide. Now, Thornton Tomasetti used SimScale to develop a digital wind tunnel app. And we're going to see today how Jeroen and his team, supported by SimScale, have done that. So I'm going to very quickly hand over to our presenters to take us through the design optimization at TT, Thornton Tomasetti, how the app was designed, its capabilities, and taking a look at SimScale's API and a shared roadmap for the future. What other capabilities will this technology enable? We are going to have a Q&A session at the end. Please feel free to start posting your questions through the GoToWebinar question panel, and we'll take some questions as we go along, and we'll take the rest towards the end. Now, remember, this series is part 1 and part 2. So part 2 is a hands-on workshop taking place next week, which you've signed up to, on pedestrian wind comfort, and my colleague Darren will give us a briefing at the end on how to join that, more details on what we will cover and why you should join. So without further ado, I'd like to hand over to my colleague, Antol Dama, to introduce himself and start the presentation. Thank you, Antol.
Great, thanks for the intro. Yeah, exciting topic. I'm glad that we can be here. So as my colleague just said, I'm Antol. I'm one of the co-founders of SimScale. Basically, my background is computer science. So I studied in Munich and in the US in computer science. And then together with a few colleagues from university, we founded SimScale. Meanwhile, 8-9 years ago, already. And basically, I worked on the let's say the backend and the infrastructure of SimScale. So basically, how to execute simulation jobs in the cloud, how to process the data, how to make all of that available online. Did that for quite a number of years. Meanwhile, and a while ago, I switched into the product management role, which is responsible for the SimScale API, which is the big topic that we're talking about today. So both the SimScale API, of course, and what you can build with it, and having this great example of this wind tunnel app that Thornton Tomasetti actually built. So yeah, I want to hand over to Jeroen to also introduce himself, and then we can get started on the topic.
Thank you very much. Thanks for having me. So I'm currently at Thornton Tomasetti. I'm an associate director within the London office and part of what we call CORE Studio, our research and development team and innovation incubator, as we call it. I'm an architect by training back in the Netherlands, but actually after studying at the Architectural Association in London, I got into the structural engineering firms and more into the computational design, complex geometry, and since a year and a bit within Thornton Tomasetti in CORE Studio. And with it, I've also specialized in, let's say, the design for urban microclimates, so CFD, thermal analysis for the outdoor worlds. And if we go to the next slide, I'll introduce Thornton Tomasetti briefly. So we're a global firm, 50 offices around the world. And as I said, I'm based in London. And within that, so we have structural engineers and facade engineers, sustainability, and myself, I'm representing CORE Studio. And on the next slide, I have a few images of some of the projects to give you a little bit of an overview. Some of the projects we have been doing worldwide, so it varies quite a bit from the super tall. So on the top left is the Jeddah Tower, the mile-tall tower in Saudi, through some bigger master planning in London, or the vessel and the shed in New York, but as well the more smaller and close to home project like the Hub House on the bottom right, which is really an infill refurbishment plus new build in the center of London. So that's a broad overview of some projects that we do as Thornton Tomasetti. And then if we move forward to actual CORE Studio, CORE Studio is involved in quite a few projects through the office, actively with, let's say, complex geometry, modeling, interoperability topics. So bringing stuff from a certain software to another software, Rhino to Revit to SAP to the analysis software, but also actually a large part of it is application development and actually writing the tools to help us do that stuff. They're broadly split out in these 4 categories. And most of them, they start internally as a direct need of what we need to do with our day-to-day workflow. Some of them, they branch out externally as well for people to use. And basically the digital wind tunnel app that we're showing today is one of those apps. And we'll see where that brings us. If we move forward, basically bringing it back to the topic of today, CFD, wind simulations. So we've been doing quite a few simulations of the urban developments, right, around buildings. So looking at pedestrian wind comfort, looking at structural loading, facade pressures, that sort of thing. Sorry for that. And combining that with thermal comfort, sometimes yes or no. Yeah, bringing that forward, actually, the digital workflows as well, right? Not just doing the actual simulation, but also actually writing the tools for it. So we move to the next slide. And if I'm zooming in a little bit more into that actual workflow of going from a 3D model to a simulation and results at the end. If we look back a few steps, it used to be quite disconnected, right? So we get a 3D model from the architects that needs to be converted, often manually, into a CFD ready model, all watertight, single surface, etc. Then a specialist basically hides in a corner for a week, does the simulation, and comes back with an answer. It's good, it's not good. And then we need to start a discussion. Okay, what are we going to do to actually make it better? And that's really what we're trying to address here. So the next slide shows a workflow that we had done before, which is already highly automated. So it's already connecting Rhino, the 3D geometry, early design models with CFD. So actually already automating that workflow, which allows us to quickly respond to the questions, get back with an answer, and run another iteration. So this workflow is already sort of a bit of a template. Can run, it's mainly based on OpenFOAM, whether it's locally or in the cloud. But it still can only be really run by a few people within the office, let's say, right? It's still a few specialists, because simulations do crash, and then you're still up for actually, you need to have the knowledge and experience in OpenFOAM, and that can be quite a steep learning curve. So in parallel to this, we actually started to use SimScale as well. And SimScale, as Anatol and Aman were saying, it's simulation on the cloud. I think on the next slide, we actually have a little screenshot of the workbench. So it has quite a few, especially the LBM, the lattice Boltzmann solver, has a few great benefits of you just drop in geometry quite quickly. So that takes away quite a lot of work in cleaning up geometry. And then quite easily, quite quickly run simulations on the cloud with a really, transient simulation with a real quick results because of the solver. Great efforts in actually making that easier and simpler. Still, I feel it's still a bit of an uphill road for non-experts, let's say, and it's still stuck within a small group within our office, and that's really where we want to push it next with the API possibility of SimScale that actually opened it up. If we move to the next slide. So that really opens us up for, again, looking back at the workflow, right? Developing an app that we could distribute through internally in the office, perhaps externally, we'll need to decide on that, but really actually making it possible to be used by a wider public. More people in the office can directly run a simulation within the app, and with the power of an API, we can actually, let's say a specialist writing that app, we can make sure that things are set up correctly. So there's quite a good quality control in the background. We can also, which is important for us, bring it forward much earlier in the design stage, because if I'm looking specifically at structural wind loading, there is the super tall buildings where we need wind tunnel testing. We need, we know that beforehand. We can do CFD to actually get to an answer earlier and then go to the wind tunnel. But there's a whole range of not super tall, but still tall buildings, let's say 50 meters to 200 meters tall, which is just on the verge of, do we need wind tunnel testing? Do we not? And with that, we're actually trying to address that. So run a CFD simulation early, get a good feel of wind loading. Often that drops like 40, 50% based on the code wind loads, and then actually use that in design, go through iterations and get on with it. And then of course, actually the whole post-processing and actually getting results back into loading into the structural analysis, and similar for comfort studies. So we were quite happy with the announcement of the API. So we've been playing a lot with it already as well. I don't know, Anatol, do you want to add anything from your side, let's say, why and how on the API?
Yeah, sure. I mean, we can also jump into that a bit more later, but I mean, for us, simply over the years, we've been around for a while, but so 8 years, 9 years, something like that. And I mean, we have the workbench, and I mean, our goal was always to make it usable, sort of democratize simulation, make it easily accessible, sort of remove these barriers of having to buy expensive software licenses and expensive hardware and all of that. And over the time, we built a significant, let's say, stack of software for handling geometries, meshing, simulation without handling all of that. And you know, we're happy about the workbench. You know, and we're not. We think it's a good tool, but yeah, simply over the years, we've heard again and again that there were sort of requests: can we use your technology in our workflows? Can we sort of, we would love to plug in SimScale into what we have. And maybe even build simpler apps. Yeah, I think you were simply turned out to be a great partnership that that on one hand you have the significant knowledge about how to design these workflows and about simulation inside your company, which is I think quite unique and great. And at the same time, you said, can maybe plug SimScale into that somehow. So yeah, I think it was just a great fit to sort of develop this API together and have you as a launch partner. And I think this is how we got here, kind of. Yeah, I think it worked out well.
True, I agree. Thank you. Yeah, so maybe we'll just show a little bit of what we've been doing in terms of a little recorded demo of. I have to say this is still alpha version of our of the app, let's say, right? But it gives you a bit of an overview and a bit of an idea of how it's working and how we're really, seeing it go forward, let's say. So at the moment, the app lives in Rhino. So it connects to the 3D geometry. And basically, you launch it as any other plugin within Rhino. This home screen is basically where your project live. So the ones that you've run, the ones that are running. But you can do, you can go to plus at the top and actually create a new project. So a few things you need to fill in, of course, name of project, etc. Then you actually click on the button Load Layers from Rhino. So that's where it makes the connection to the 3D geometry in Rhino. You see the layers table on the right-hand side. That's the ones that are picked up there. And with a few very small amount and simple screens, you really go through setting up the simulation. So in this case, I chose for a structural loading study, choose, let's say, 3 different directions, setting in, let's say, the terrain conditions. So imagine, let's say, London, where you have the river, or New York would even be more pronounced, let's say, right, the East River and the Hudson River. You have different terrain conditions on either side of a building. You go through 2 or 3 more windows of actually setting up, okay, I want actually forces around the proposed building. I want to cut a horizontal or a vertical plane of results. And then it starts, that's it already. Then it starts preparing the simulation. So at this point, the app starts talking to SimScale. So it packages up the whole simulation. Maybe we want to stop it here for a sec. So it packages up the simulation, starts preparing the whole thing, sends it to the cloud, to the SimScale platform, builds a project there, treats all the inputs, and then it actually gets an estimate of runtime back. So up until that point, so that's basically just the previous screen, just before we paused it actually. Then it reports back to the user, okay, the simulation is going to cost X amount of GPU hours, money, let's say $65 or something, I think the example said. And that's when the user can click OK, and that's when you'll be on the hook for the hours, let's say. Before that, exactly, so this is the summary screen. So you'll just have a little think about it. Okay, do I want to run this? Is it all good? And then when you then click OK, it actually starts running the simulation on the cloud. If you play the video forward, then we can see that. So I think I'll switch over to the SimScale workbench as well in a sec. And then you see actually the simulation built up, the geometry, same as in Rhino. You see it in the workbench, and as well the 3 directions, the 3 cases start running. So for people who use SimScale, this is hopefully familiar face. So it's a full project. It's equal to, let's say, a project you would build on a workbench, but in this case, it's actually built in Rhino through the app with the API. And you see the 3 simulations running in the bottom left, the 0, the 45, and the 90 degrees. And then following on from this, at this point, we're actually pulling the download as well. So once the simulation is done, I don't have it in the video, let's say, but once the simulation is done, it pulls down the results to your local hard drive, and you can actually interrogate it. In the next few weeks, we'll expand that to actually really visualize it back in Rhino as well through the app. So you'll go back to that first screen in the app that I briefly mentioned. So that's where your project will be parked. So you'll go in there. That has a connection to SimScale again. So that is your project on SimScale. Download this specific direction or this comfort or this CP values on the facade, let's say pressures on the facade. And then you can visualize that back in Rhino. And if I'm talking 1-2 steps further down the line, we actually want to use that same app, so the framework as it is at the moment, but actually integrate that into the structural software. So with a bit of post-processing, you then actually run from the structural software. You can run your simulations and actually directly import structural loading on, let's say, the floors. directly into your structural model.
Nice. Maybe one thing to mention. So I think it's good that you showed also the workbench. That it's sort of like a full project in workbench as well. So what it also allows you, and I think this was also one of the ideas behind the design of the app or the imagined workflow, is that you can still have both SimScale support and also experts within your company actually go to the workbench and maybe fix certain things, or something is not working after all. You can actually also provide assistance via the workbench, which is, I think, quite convenient to have.
No, exactly. We've been talking a lot about that, actually, right? So the app is really for, let's say, the larger pool of engineers that are maybe not CFD experts, but can quickly run a simulation without having to leave Rhino or having to leave ETABS structured software. If all goes well, hopefully we set it up well, and if all goes well, actually they don't have to really interfere. But at the same time, we have a small pool of the CFD experts. We can always go in, exactly as you say, go into the projects. The project is shared amongst ourselves in the enterprise pool, in the enterprise group, let's say. So we can always go back in, check things, and run an additional simulation if necessary, fix some things, and go on again. Yes.
Yeah. And also, I mean, because you showed the cost control, I think it's also nice because you can also then, you get a sort of good feeling for the value you get out of it. Maybe in an early design stage, it doesn't have to be as accurate. So you say maybe you go back a step, you maybe just decrease the mesh fineness, which is easy, which is just a drop-down menu, right? So anyone can do it, and you just check again. Is this now within the budget? And then you can sort of do more detailed simulations later and all of that. And I mean, this is both of course controllable by the user, but you can just as well sort of encode some sort of policies into this tool or some workflows that you would like to actually have. Where you say, okay, for a certain project, you want to have certain minimum amount of mesh fineness, for example, because that project requires it. All of these things are of course possible in an app like that as well.
No, that's right.
Yeah,
go ahead. Sorry.
Okay, yeah, I was going to say this comment Antal just made about the cost and having this visibility is so important, especially for, like you said, your own larger organizations who have multiple consultants, engineers, architects, dipping in, dipping out of the simulation who aren't necessarily experts, because it gives you some control, right? You don't want someone accidentally firing off a simulation that's going to take 3 days and consume thousands of dollars. So this is perfect to manage that quality from a smaller group of expert people and admins as well, right? Especially if you're deploying it to a large number of users in a big organization like yours.
No, exactly. And it also gives a bit of choice, actually, right? So you could choose for the simpler but cheaper options much earlier on, right? Early stage. And it could be the decision to the design team to, like $65. Yeah, we can probably absorb that in the cost. But if you go a bit more detailed and a bit more elaborate simulations, where you actually do want to have the full bells and whistles, and it's maybe, I don't know, $300, maybe $1,000, who knows, right? At that point, you can choose, okay, wait, let's hold on, actually, let's first call the client and discuss, like, okay, this is a bit more involved, and it might be actually additional fee, right, or something like that. So exactly, it's being ready for surprises and being ready for choice on where the different levels of detail matter, basically, right?
Yeah, and the good thing is that you can do a simulation for kind of $50. That's fantastic. It's making simulation accessible, especially at the early design stage where you just have, you don't want it super accurate, and the time is more important, like competitions or when you're iterating through designs, various designs. The fact that for, a few tens of dollars, you can run this high fidelity simulation on the cloud using a well-known CFD software is brilliant. That's making CFD accessible because it's on the cloud as well. It's making it accessible to basically everyone and anyone. So I think it's a great approach. This transparency that's here with the time and cost is absolutely fantastic.
And also at good turnaround times, right? I mean, so if you look at the model, it's not exactly small, let's say. And I mean, especially this solver, we're quite happy to have it in our platform. I mean, it's GPU based. I mean, these are details which are not so important for this webinar, but it just scales very, very well. So you can have really very quick feedback on any kind of simulation you want to run. Especially, for example, if you run wind studies and you want to run, I don't know, let's say 16 directions. I mean, first of all, you can run them all at the same time because it's cloud and it's an online solution. And even the single runs themselves are also usually just quite fast. So I think it's nice to get quick feedback as well.
Just a reminder to everyone watching, please do post your questions using the questions panel on GoToWebinar, and we'll take all the questions for Jeroen and Anatol in a few minutes.
I think that was it in terms of demo, let's say. I think we can take a step back and zoom out a little bit again. If you move to the next slide.
Sure, and if there's any questions later about the demo or the app, then of course we have to answer.
We can always grab back, let's say, right?
Nice. Yeah, great. I mean, thanks for the demo and the also to explain sort of the evolution of this project so far, right? Where you came from, which steps you took, and where we are right now. I think it's also interesting to hear this sort of journey, which I mean, it seems the AC space is taking this journey more and more. So I think it's good to hear that and how it can lead to something very positive and modern. So that was great to hear. Yeah, and then I mean, of course, me having a computer science background, I couldn't quite resist putting some code into the slides, into the webinar. But yeah, I mean, I hope it's not scaring anyone off. The idea is really to just show what this API actually looks like, because an API can maybe sound a bit abstract, or what does it actually mean? How do I actually create a simulation on SimScale using the API? So I just showed a very quick, very small example of a wind comfort simulation. So you can see this is Python code. So we have SDKs, basically sort of kits to get you started in Python and C#, which seem to be common languages for the companies that are interested in this. And you see, I mean, it's quite simple actually. So I mean, if you have used our workbench, all of these concepts sound familiar to you. So for example, the area of interest that you define for your wind simulation, or the different velocity for the wind and the roughness of the surfaces around that. I mean, it's all quite, or we hope it's quite intuitive to also use this actually in the code and not just the workbench. So all of the concepts should be familiar, and you have the software development kits which will help you actually get started and not make any mistakes while you write your code. So you can basically create a full simulation setup, including result processing in, let's say, a few hundred lines of code, depending, if you maybe just want to change certain parts of a simulation that you have already in the workbench. It's even much less, it's just a few lines of code, but the full setup would be that. And we also have templates for the most common API use cases. So for example, if you want to do, let's say, a parameter study, maybe not so much in AC, but in a different space, or a wind study, all of these have Python and C# templates to get you just started quite quickly. And yeah, and what I also wanted to show you beyond this is just sort of the, let's say, the history and the future for the API. So you can basically see the timeline that we're talking about is the first quarter of this year, so where we are right now. Then sort of looking into the future for the next quarter, what we have planned, and then sort of concluding that until the end of the year, what our plans are. Basically where we are right now is we have the API fully functional for our LBM solver for external aerodynamics. So this is basically what this wind tunnel app is also built on and based on. And of course, we have our launch partner, Thornton Tomasetti, that built this app. We're quite happy. So I think we got a lot of good feedback on what this API should look like, how it should behave, what kind of tooling support we should have. So we hope that we design something that is a good fit for anyone who wants to actually build something in that space and that is intuitive to use and all of that. What we also built, there's going to be probably a separate webinar, or at least a blog post on that, is actually integration. This was outside of the AC space. I just want to mention it because I think it was also a very exciting and interesting project. This is actually a car battery, so it was in the electronics cooling space, where the idea was to sort of build an integrated optimization loop where we use the software. So we have a software partner in this case called Numeric Systems, which have a software called Optimus, and you could basically couple that software to our API to sort of automatically run design studies on this battery and parameter studies on this battery, and simply see how the cooling performs, and then basically arrive at an optimal battery design. And that was also quite exciting and interesting. So we'll talk more about that later in different venues. And where we're going, so this is where we are right now. We are going next quarter. We will also have support in the API for our CHG solvers. So if you want to do any thermal simulations, either for also the AEC space, but also for electronics cooling, for example, and so on, we are also going to have that. So basically the full capabilities of OpenFOAM in our API as well. What we're also going to have, at least in a sort of private beta, something which I think is quite cool, is actually a post-processing API. So for example, if you want to, so I think there's lots of value in what Jeroen said before in the app, that you export results back into Rhino, for example, visualize there. Maybe have a workflow where you then send the data to ETABS or SAP and do structural analysis. That's great. But of course, we also have many cases where you actually want to look at, for example, some streamlines of your simulation, or automatically generating images for reports that you maybe then want to hand on to your customers or external partners. So we also have a running, right now it's just an internal sort of project inside the company, a post-processing API where you can just export videos, images, and all of that by the API. What we're also working on, of course, is more integrations. So there's just dozens of interesting software companies out there which do things like shape optimization, shape generation, design of experiments, all of these things, right? And we have many collaborations ongoing there right now as well to integrate our API. So keep watching. We're going to have lots more webinars and case studies out there as well. And then sort of to finish it off, the plan or the roadmap for our API, we want to basically make it feature complete. So everything that works in the workbench, we also want to have in the API, of course. And the idea is to conclude that or sort of finite element analysis in the API as well. And of course, also releasing this post-processing API to the public. So right now it's working internally, but we of course also want to release it at some point. And basically what I also put here, so the API is currently part of our paid enterprise plan. But we're always open to, so if you come to us and you say, it has an interesting idea for an integration, or you would like to integrate our software or a proof of concept or a case study, please get in touch. So we are always open to collaborate, get feedback, and sort of promote this together. You can definitely check out our Python SDK, which is public. So you can see the examples there. You can see how it works. Get in touch if you're interested in working together. And I think that actually concludes our main content. And of course, we're open to questions. So I'm sure there's many things that might still be a bit unclear, or where you might want to get some more information. So
Thank you, Anatol. We do have some questions. I guess this is a good place to ask Jeroen then. You can see the roadmap there, Jeroen, for other types of analysis with the SimScale API. You mentioned earlier as well other things you will be looking to integrate over the next 6 to 18 months. What would you love to have in your app integrated? What other types of analysis?
So I think the app itself, we'd love to integrate that into more softwares, right? So going into, let's say, ETABS for our building structural analysis, or SAP for the more complex geometries, or the other way around, right? Like actually moving away from Rhino, but also integrating with Revit and stuff like that. Like, because we've built the app specifically quite modular, that we can actually port it quite easily. So that's the app specifically, and I see the app much more as this lightweight entry getting into CFD. On the other hand, I'm quite interested in the optimization actually, because with the whole Rhino and Grasshopper environment, you could also write smaller applications, but much more granular and geared towards that optimization. So you could actually run a building shape optimization of, let's say, reducing harsh wind conditions on the streets, or reduce the loading on a building, right? Like make it respond better, that sort of things. But then within Grasshopper, let's say, you could actually run a genetic algorithm where you actually run CFD simulations in the background and get the results, evaluate the metrics, and based on that, change the geometry and run it again, right?
Absolutely.
And especially for that, you have a cloud backend, because if you're doing this on your local machine, then you're not going to have fun.
Absolutely, absolutely.
Jeroen, digital transformation is happening everywhere, and our architecture, engineering, construction industries, this is also critical for them to be able to transform their organizations and move to the cloud and embrace new technologies. And your group, core group, that's one of your missions, right? To kind of stay ahead, your early adopters of new technologies. Exactly. And so you've been transforming Thornton Tomasetti, the organization has your early adopters, you like new technology, you experiment with it, you create your own tools. Definitely you're some of the early adopters. How important is it, tools like SimScale, which are totally cloud-based, cloud native applications in that journey towards digital transformation?
I think it's extremely important, and more actually. Like we see more and more applications on the cloud. We're building our own cloud-based applications as well, let's say, right? So we actually have some lightweight viewers and data dashboards, data visualization tools like Mirar and Thread that we build in-house are fully run on the cloud. So CFD running it on the cloud, that's just a natural extension, to be honest, in that respect. I think, it's the answer. Like it's not even a question anymore, almost.
Exactly. We have a couple of other questions. Thank you, Jeroen. We were talking about outdoor comfort earlier, Jeroen, before the webinar started. And again, there's a lot more interest in this. We mentioned the new City of London guidelines on outdoor comfort. How important is that? And how at what stage would you typically do an analysis like that? Is that also something that lends itself to very early stage design? And would your app eventually, or maybe a wish list of yours, to include that kind of capability in there?
Yeah, it does. Actually, we're even towards client, we're pushing it. Let's do it early. Let's do it as early as possible in the concept design stage, when you're still, because the thing is, when you're still actually designing a master plan, right, you can actually change the buildings, right? You can move them apart, you can rotate them, you can orient them so that it actually, the effect is largest, right? When you start moving into building design, you're actually talking about much smaller interventions, right? Balconies, canopies, that sort of thing. So you can still do things, but the effects are actually less. So with all of these tools, let's go earlier. Maybe they're rougher and less precise, but having an early answer, any answer, is already better than no answer in a way.
Yeah.
And then, as you mentioned, the City of London has now approved and established these thermal comfort, outdoor thermal comfort guidelines as well. So they're testing them. It's not officially a ground to pass or fail a planning, but it is part of the planning application. So yes, it's becoming more and more important, and for good reasons. We want comfortable outdoor spaces, right?
Exactly. Yeah, that's fantastic to see some of the great work you're doing. I guess what I'd like is invite both of you to give some closing remarks. Maybe Antol, if you give your remarks about the API and the usefulness of an API for in general, and how organizations could leverage that.
Yeah, sure. I mean, it's actually a tough question, because it's just endless kind of. I mean, we've been building this API for a while, and of course, I mean, we have a wide customer base, right? So we've been talking to many people about how they would like to leverage an API, and what they would like to have, and and sort of which kind of features, what kind of interfaces, and so on. And it's just, it's too much to talk about. There's just too many different ways you can leverage it. There's so many different ways you can save yourself time by automating tasks. And sometimes we've heard from users setting up dozens of simulations manually. That doesn't make any sense. That you should automate that, of course, or integrating different softwares, establishing workflows. It's just endless. And of course, there's a lot of software out there which is actually aimed at different sort of markets. For example, also in the AEC space, there's BIM solutions and so on. I mean, why not just have a sort of a way to run CFD studies in such softwares? And if you have an API, you can of course easily integrate it as well. And it's the same in every space, and not just in AEC, of course.
Absolutely, and I think the fact is that not everyone can develop a CFD software. This is difficult work. It's complex. It requires a lot of resources. But then you don't have to, because if you tools like SimScale, which have an API that anyone can connect to on the cloud, gives you that capabilities. So the very simple example I give, this is very simple, is imagine you have a Samsung phone, right? The SimScale is the Android that's powering it, right? And then on top you have Samsung with their own features, their own apps, their own capabilities. It's a very simple way of looking at it, but not everyone can develop Android operating system, right? But what we're doing is giving the power of the simulation engine in SimScale, opening that up to third parties to be able to develop and customize their own tools. Would you agree with that, Antol?
Yeah, I guess the short answer is yes. And yeah, I mean, let's put it this way: not everyone should have to develop Android. I mean, maybe you could if you had an enormous amount of time and money and patience, and let's say tolerance to frustration, because simulation is tough. Maybe you could, but you shouldn't have to, and you don't have to anymore.
No, I know. Yeah, exactly. I was going to say the same, and you shouldn't want to either. Let's say, right? Like, as a if I'm looking like selfishly as a consultancy firm, we'd rather get on and do the job, right? Like do the actual wind simulation. And for that, we just want to use the right tool around rather than being stuck in some sort of software. Actually, the whole ecosystem of APIs. Actually, I was talking to one of the executives quite recently. He says actually simply, we shouldn't even buy any software anymore if they don't have an API. Like it's natural almost now. Like, we need to move stuff around from software to software. Let's make that journey as smooth as possible, and use the right tools and validated tools. That's often important in terms of engineering as well, right? Let's use the validated tools for that rather than inventing it ourselves.
Yeah, exactly. Absolutely. I mean, trust and confidence in the results is absolutely critical. Jeroen, let's take one more question from the audience. So we have an attendee asking, you briefly touched on this earlier about the app being available outside of Thornton Tomasetti. I guess what's your kind of plan or views on that moving forward? Not necessarily right now.
I think the honest answer is we're still figuring it out. So this is quite similar to many of the other apps that we have been developing within CORE Studio, right? So they really start as a direct need from ourselves. Like, we want to do this. This helps our workflow. But we also see the benefit of, even in beta version, throwing it out to people, inviting some select people already in beta, and also developing it further. If I'm looking at Construe, actually, that's like a paid model at the moment. We've just started a license on Asterisk, the machine learning engine, in terms of sizing columns for parking garages. So there is ways to do that. And I think for this, there is also, positive things to actually make it accessible for externals as well. So yes, I think we will. I just can't give a fixed answer yet how that looks like or when exactly, let's say. I think in the next, I was going to say 2-3 months, I think it's going to be a lot more clear, I think. So we should maybe follow up on that.
That's interesting. If you feel this is something that they say, okay, this looks convincing, or this is something that we can imagine also using, then please get in touch that we can talk. I think it would be interesting to hear from you as well.
Great, thank you so much, Jeroen and Antol, for joining us today. This, like I said at the beginning, this is such an interesting topic. I feel like we could talk about this for another 2 hours. And I think the interest we've got is really amazing in this, and we'll be following up with a blog about this topic. So please watch out for that. I'm going to hand over to my colleague Darren Lynch to talk about the hands-on workshop briefing, which is taking place next week. Before I do that, again, I'd like to thank you so much to Jeroen from joining, from Thornton Tomasetti, and all the fantastic work you've been doing.
Thank you very much. Thanks for having me. Thanks everyone also for listening and attending. It's been great. It's been a great journey and good to be on the webinar. Thank you.
Thank you, Jeroen. And likewise, Antol, I mean, you've already said if anyone has ideas or they'd like to discuss something about the API, you can see the email address here on the slide. Do get in touch with Antol. Thank you, Antol.
Great, thank you. Great to be here.
Thank you so much for joining this webinar. We hope you enjoyed it, and we will close the webinar there. Thank you and good night.